Hello. All right. And this is effectively the lab continuation. The lab, and this is the continuation of what we started in the lecture. So it really isn't lab per se now, it's just finishing up the lecture topics. So the lab is going to be dedicated to presentations, which we are going to start next week and continue on the following week. So be ready, we will discuss more of that soon. So we need to get this done so that we can do the presentations either in lecture or in lab, depending. But I'm happy to have it done that way. So let me get back here and we will look. So here we go. This is kind of where we're looking. So you'll remember this is where we were last time. This is the anatomical portion. That's critical. And I'm not going to go into it clinically. This text 3, 4 years ago. So the statistics are probably in that 4 year range, I would say. Cervical cancer, as you can see, a worldwide killer of notoriously, typically in an age group that we would that's very unfortunate because these are young women who are there. And it is not exclusive to women. Cervical cancer obviously is, but you can have penile cancers as well. And the underlying source for this, human papillomavirus. There is there's been an immunization out for a number of years called Gardasil. There's also one, I mean, I think it's the same one for boys. They target, there's X number of strains, there's quite a few strains of HPV. They do by number, and basically these vaccines are created to the ones that are the most common offenders, because certainly not all HPV. Human papillomavirus basically causes warts of all type. And this is where the pap smear comes in, and I don't, to me, it's not critical. We're not doing a course in OBGYN to comment on the appropriate time for evaluations and what's involved, but basically a series of smears, traditionally called PAP or Papanicolou smears, are used for detection, and they are designed basically to look for the specific cellular abnormalities. You can look it up; they'll be published all over the place with a lot of images, and it's been a very useful test. So I thought I would mention it basically because, in my opinion, and most of the statistics will bear you out, this is the most common of all the sexually transmitted diseases. In a sense that not only it's not about new cases every year, but once you have it, you have it. It's not something that goes away. It's not something that disappears. It doesn't mean it's going to harm you, but it means you've been exposed to it, and so the potential of harm still exists. So I think that's worth noting for everybody. And we saw this illustration before. This is the idea from the side. This is called anteverted. This is the typical position, which is interesting during pregnancy. Obviously, the positioning between rectum and bladder puts a lot of pressure on those structures and accounts for some of the varying things that women experience on an ongoing basis during their pregnancies that are there. And there's some changes to this during the human sexual response, where this begins to tent, becomes more vertical, what they call retroverted, goes backwards, which facilitates the fertilization process physiologically. Prolapse is something very, very well known phenomenon, usually done from childbirth, but can be associated with other things. There's a lot of pelvic floor. Remember, the pelvic floor is not a bony structure. The pelvic floor is a soft tissue structure that's easily damaged over time. I mean, secure, but as a function of a variety of things can weaken it, and it's a relatively common problem. You might remember me telling you that they have. Beg your pardon. As I get up and walk around because the pooch is, as usual, into stuff he shouldn't be into. That's just you're a pooch, and go ahead, take my chair. See if I care. And so, to sort of go into it in a little bit more detail, what it means is my mom had this problem that tended to cause a certain amount of leakage. Uh, there's a there's a at McGee. There's a whole area of surgery that's called pelvic floor surgery. This people who specialize strictly in this kind of an intervention. So it's well known. We'll get into the functionalis and basalis, review them. The functionalis is always there. The basalis is always there, and the functionalis is hormonally responsive. And you remember this is really very, very well developed endometrium. Here's the base layer. Once you start to see these large uterine glandular structures, and by way of their secretions, they really facilitate uh, the ability for a satisfactory degree of implantation that's there. Let's see. Here are the uterine arteries from the internal iliacs, and effectively what they do is they arch in the myometrium, and then they go kind of straight into the endometrium, and then you develop those spiral arteries. It's their spasms that, as you might recall, are the ones they spasm that eliminates the blood supply, causes the layers, the functionalis and the basalis to separate. And then when the spasm releases, you've built up a pressure head, and it kind of basically allows it to slough. So it's a combination of fluid, of blood, and of cellular material. It's not all blood, which is a misconception. It doesn't take a lot of blood for something to look red. That's the idea. I mean, we say it all the time. A thimbleful of blood could turn a bucket of water red. It doesn't take a lot. This is a good illustration to show the spiral arteries, etc., with the glands in a well-developed endometrium. This is basically this is vaginal anatomy. Nothing special about that. Any of the stuff we review this in anatomy, and we're not going to go into it here. This is an interesting nugget physiologically. When it was one of the reasons for the initiation of Roe v. Wade, whatever your opinion is with regard to anything along those lines, is the idea is that what was being done were people who were doing abortions inappropriately, people trying to self-induce them because they didn't understand the tenting and the normal curvature, and it was so much damage done. It was just awful, terrible infections, gangrenous infections. It was just a nightmare, and that was probably at the time there was so much of that was going around that was probably the underlying theme in what would certainly have been different times than they are today with the constituency of the Supreme Court for this to occur. Again, I don't get into the debate about who's right or who's wrong about that because it's a science class. We're not talking about ethics and law and things like that are there. The rest of the external genitalia that's there, etc. Voila, voila. Mammary glands, same thing. The mammary glands are part of this. The glandula itself is most likely an apocrine gland, as you might recall, but in the female breast, it's more fat than glandular tissue. The glandular tissue enlarges during the pregnancy and lactation. Okay, not a whole lot is associated with that. And then, of course, the tragedy of breast cancer. It's talk about common. When you get to prostate and you get to breast cancer, we're not talking about necessarily entirely always lethal cancers, but from a standpoint of frequency, with the exception probably of skin cancer. And because statistically, probably 1 out of 4 to 1 out of 5 of us will probably carry a diagnosis of some juncture of a skin cancer, typically the basal cell carcinoma, but that's very, very easily treated by removal, doesn't require aftercare. But breast and prostate cancer, you're looking at an inordinately large amount, and even more so for breast than for prostate. These are glandular cancers, hence the name adeno for gland carcinomas. All of these things, early onset menstruation, late menopause, no pregnancies or first pregnancy late in life, breastfeeding, no unsure periods, family histories, and a variety of other factors. And you'll see in the PowerPoint, they even comment on the fact that even that is to some extent not terribly reliable in the standpoint that 70% of women with breast cancer have no known risk factors. And if you want to go back, and we talked about with men previously, are we dealing with things that are in the environment? Are these impactful? Are there toxins that we've encountered? How well has it been studied? I don't know. I know in genetics that you certainly are familiar with the BRCA1 and 2 and their strong association and the extraordinarily risk and very often the election to have uh, by almost bilateral mastectomies, which is we think of what kind of a decision that would be for anybody because of the risk factors. And I usually tell the anecdote about my cousin whose wife, whose mom, and I think a mom and an aunt died very young of breast cancer, got the diagnosis, elected to have the bilateral mastectomy. She already had 5 children, mind you, and biologically. And then they did the reconstruction. They had a world of problems post reconstruction. on one side. And thankfully, the last time I saw her, which is a number of years ago, my mom's funeral, uh, was doing quite well. Mammography number and all that type of stuff, and the different treatments. And again, that's not necessarily for us. It's less so physiology than more of just completing, a certain degree of understanding and a certain degree of material on the topic in and of itself. This is really an important topic, and it needs to be discussed or at least described. So here we get into the physiology. Same deal. Now we're here. We're here into the gamete and oogenesis, and effectively, primary oocytes form. Depending on who you read, we're looking at maybe 450,000 approximately in a woman at the time of puberty that have formed, that undergo meiosis one and are arrested in that stage, as you will see. And you can go through this in greater detail in other courses that are that are there. So the primary oocytes that undergo meiosis one to produce the secondary oocytes, the meiosis two, etc. And so we'll go over more of this. So primary oocytes are fetal. It's arrested in late prophase one and resumes only years later, if at all. And that's only if that's the egg that's selected. The secondary oocytes, meiosis is arrested at metaphase two and completes itself on fertilization. So that's after it has been ovulated out. So at birth, females are presumed, as we see, a lifetime supply of primary oocytes. And what makes the selection, how we can, and there's a lot, particularly if you get into the ins and outs of in vitro. And again, I have experience with this not only because of our own infertility. My two youngest grandchildren are products of in vitro fertilization, and then you all had heard that my daughter was an egg donor on multiple occasions. So what happens is this is the follicle, the functional unit that encloses that oocyte, and it forms from these granulosa type cells. Okay, if more, so we have pregranulosa and granulosa cells, and there's a developmental process, and without getting into the cellular constituents, starting with primordial, which means an undeveloped follicle. So eventually it develops, and so sooner or later, before birth, we go through the follicle. Okay, throughout life until menopause, these primordial follicles begin to grow and develop before puberty, all developing follicles and undergoing atresia. So these are all arrested in prophase. This column shows the development of the oocyte inside the follicle. Prior in blue, we have prior to birth. So here's the primary oocyte, here's the primordial follicle. And eventually, these will all be in the form of primary oocytes. These are the ones that effectively are selected. It's the ones that we follow the pathway of the primary oocyte, whichever one from whichever side is selected on a monthly basis. So as you can see, primary follicles, single layer, secondary follicles, multiple layers. When you get to the antrum, the so-called tertiary follicle or antrum, the follicle with the antrum, another name that you see utilized for this is called graphian. Capital G, its proper name, capital GRAAFIAN, I believe is the spelling. That is synonymous with this tertiary follicle. It has the antrum. That's the follicle that's matured and ready to ovulate. So the primary oocyte inside that vesicular or antral follicle resumes meiosis, arrested then before in meiosis two before the completion, but at ovulation, it becomes the secondary follicle. Here we are throughout life until menopause, the primary. Now, here's the formation of the secondary follicle. As we see the follicle development, still a primary oocyte. So in puberty, after puberty, some vesicular follicles are rescued from atresia each month, and the primary oocyte in one. So once it gets there, it's basically ready to go. Becomes the dominant follicle and completes meiosis one. So it completes in that follicle just prior to ovulation. Then it's ovulated out. So here you can see the meiotic events where they're just showing you an idea of where a spindle is. And what happens is it completes it and becomes the secondary oocyte being arrested in metaphase two rather than late in prophase one in the earlier case. It's you call it an asymmetrical division. What you have is an actual follicle, and you have the other genetic material with an insufficient amount of other material, and it's called the first polar body, and it sloughs and eventually decomposes. And then finally, there's ovulation. What's left of the follicle becomes very famously the corpus luteum, and that luteum because of the yellowish color, and that becomes effectively an endocrine organ to produce things like estrogen and progesterone, and most notably HCG, human chorionic gonadotropin, which is the in large quantities that are the first sign of pregnancy and part of the obviously the early pregnancy test that very, very familiar with, and very, very reliable. And as you can see, once it's been fertilized, assuming that that occurs and the corpus luteum forms, now you have a fertilized egg. It completes meiosis too. We have the zygote. Now you have a second polar body when that divides. And that, again, that sloughs and deteriorates or undergoes some degree of atresia. And voila, it's done. So at that point, now we have the zygote ready for fertilization, and we have within the ovary the corpus luteum. The question is if whether or not it implants. If it implants successfully, this will then take over until the placenta develops. If it does not, this will deteriorate in roughly 10 days. And because of that deterioration, hormones stop being produced, and we develop the phenomena that we call menstruation because of that spasm in the spiral arteries. Da, 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 da. So you can see only a small refraction, apoptosis or atresia. So 99%, nearly 100%, 99.9% of all follicles never recruited. Each month after puberty, there a few primary oocytes develop. Okay, so it's not more than one, but effectively only one is really selected to become the dominant follicle. Resumes meiosis one just before ovulation. It's completed. Then you have the first polar body, no cytoplasm, gone. Secondary oocyte is the one that effectively arrests in metaphase 2 and becomes ovulated. And then what happens? Either it deteriorates or it doesn't. So the ovum, the large cell with enough cytoplasm to nourish the fertilized egg for that journey, which roughly takes a week, okay, to get to the uterus, etc. And here you have that. So typically one viable haploid ovum with 2 or 3 haploid polar bodies. Okay, and so versus 4 viable sperm, and so there's a different rate that's there, and it's not a big deal. That's again the distinction is between in men. This is a process that goes on in women. Effectively, it ends at menopause. So you can see all of this. The table that takes it. They're looking at the stages of follicular development, pre-antral phase, before that antrum forms. In the development process, as you can see, it takes quite some time, a year to mature before really there can be any degree of. So the ovulation is ongoing, the maturation rather is ongoing. Okay. And it's involved with a number of localized chemical based things, interfollicular paracrines. And then the antral phase, which is stimulated by FSH and LH, that's a big play that's there. And the dominant follicle then is selected, and voila, off we go again. So primordial follicles, they're talking about them, how long the process takes, not a big deal. So you can see this oocyte, the follicle, involves something called the zona pellucida. It's also worth knowing or remembering all of the different cell stages that are there. And so there's a lot of names, okay? And they go into it in quite a degree of detail, but I don't think it's extraordinarily necessary to recall all of this. So finally, the secondary follicle becomes that antral or Graafian follicle. Okay, when there's a sufficient amount of liquid, that liquid is going to exert a certain degree of force that that is associated with and part of the ovulation portion. Is going to facilitate that pressure head against what effectively is a weakened ovarian wall and allow it to be expelled during ovulation. That's the antral phase. Okay. Here's where we get to see the name corona radiata again. There's more than one of those. You see in a lot of different places. And again, once it's out, the secondary follicle becomes a vesicular follicle, and after the ejection of the secondary oocyte, now we have the corpus luteum. So they're showing you all that. So all of this, and to summarize, I'm going to end with this little section here. The ovarian cycle, roughly a 28-day series of events. There is the interesting that the number of days is not 100% consistent. Okay, it is not. The ovarian cycle is has a sudden degree of variation in the follicular phase, not so much in the luteal phase. Once it ovulates, it's 14 days. That first part of the phase could be 13, could be 15. Okay, ovulation is roughly mid-cycle, so you can see a limited number of women, and anecdotally, you can talk to people and find out, if that applies to them or not. Okay. So there can be a lot of variation. Is there again with my first wife's cystic ovarian disease? It's hardly a clock that was there, and it's the cards more dealt. Okay, with all of these things. So you can see the luteal phase is consistent, the dominant follicle. So during that follicular phase, those antral follicles, one is selected to the dominant follicle. It's very sensitive to FSH, the stimulating hormone. That level drops around the middle of the follicular phase, and the dominant follicle basically continues on. The other ones undergo atresia. So the primary oocyte of the dominant follicle completes meiosis 1. Secondary oocyte in the first polar body, the granulosa cells then send signal to the oocyte, causing it to stop meiosis. So that's it. And then we have ovulation. That antrum in the wall, that antrum facilitates the ovarian wall rupturing it along with the chemicals that are involved, expelling the oocyte. It has that corona radiata just around it. Think of it as being protective. In the German, they call it Mittelschmerz. You may have heard the expression that some individuals feel. Obviously, I don't know anything about it. We, for the longest time, and you still see advertisements on TV, it's called BBTs, basal body temperatures, in an effort to see if there's a subtle, very, very tiny. So you're not looking at 98.6 to 99, you're looking at 98.6 to 98.7 or 98.8. So you have a special thermometer now with digital, it'll be a lot easier. So 1 to 2% release more than one secondary oocyte because they're different genetically, they're fraternal. If the one after fertilization separates, it may form 2, even more daughter cells conceivably, and that would be, as we would all know, identical twins. Okay. And even there's some on relationships. There's inherently a lot of complexity to this. So after ovulation, we have the luteal phase, meaning the corpus luteum takes over. Okay, the ruptured follicle collapses, corpora hemorrhagicum, and it's absorbed. But what's left of it, what you want to know is the corpus luteum. It's mostly progesterone. Estrogen predominates early, progesterone predominates later, and we're going to go into all of that. If there's no pregnancy, it becomes what they call the corpus albicans, indicating it's white, it's scarred. In about 10 days, back. And the endometrium erodes right after that 10-day period. If pregnancy occurs, the luteum takes over. And look, it's about 3 months that it's going to take over until the placenta gets established. So you have a whole first trimester conceivably that would be part of it. So I'm going to stop it there, and we're going to look at all the regulatory events shortly. So thanks again very much for your attention, and I'll get back to you.